Hello, welcome to the last part of 5.1 acid-base concept lecture videos. In this video, we'd like to talk about the third one down in this the concepts that would need to be covered. Acid-base indicators. They are weak acids or bases where acidic form is of a different color from the basic form. So we're looking at the indicators. Okay. So acid-base indicators, they indicate pH as and also well, by changing its colors, they show how strong, how weak they are, if they are, I don't know, the same concentration, or how concentrated, how dilute they are as well. Weak acids and bases, that's what they actually are. So if you put acidic solution and if you add some indicator into it, you're actually looking at acid-base reaction. But because in all the indicators are very weak acid or weak base, they don't really contribute to alter the pH of the solution that you are dealing with. Where acidic form is different color from its basic form, that's what really is. Depending on pH or depending on acidity or alkalinity, they change its color. Common indicators can be found in this diagram. Now you can try copying that and just using words to indicate what colors they would have. So I'll zoom into that. The universal indicator has got a range of color, like it changes right rainbow from red to purple. For phenolphthalein, if it's acidic on the left hand side, you will see no color, it's colorless. And at pH of 7, it's still clear, and then once it becomes a bit higher, then you start seeing very faint pale pink color. And after that, it will become bright, shocking pink sort of color. So in basic condition, phenolphthalein will be very dark pink. Methyl orange changes from red to yellow, and the color change occurs towards the acidic side, so less than 7. And thymol blue changes from pinkish color to blue color, and yellow is in the middle. And the range of the yellow is quite big. So personally, I've never really used it. Bromomethyl blue, I hope I'm saying that right. That changes from yellow, green to blue. And finally, phenol red, so that changes from yellow, pink in the middle, and then darker pinkish color, or could be reddish color. Now, one important one that you should memorize is the phenolphthalein one, because you'll be using it again and again. If it's acidic, it's colorless. If you're aiming at a neutralization point, so all the number of acids and bases are the same, you should be able to aim at very pale, very faint pink color. And in anything that's higher in pH or a very basic solution, you should see bright pink color. All right. Moving on to universal indicator. Again, universal indicator has got range of colors. That's because universal indicator has got a mixture with different compounds, different indicators. That's why it exhibits several smooth color change over pH value from 1 to 14 or 0 to 14 there in the diagram. When it's neutral, it should be green. but yeah, only I guess bad thing about it compared to phenolphthalein, for example. Phenolphthalein only has basically two colors, or colorless or one very shocking pink color. The changeover point is very narrow, so you can accurately say that the neutralization point occurs at certain point, whereas for universal indicator, it's useful for finding out pH of a solution, but there is no because the color change is so gradual. You can't tell the exact moment where acid changes to base or base changes to acid. So yeah, that's the only, I guess, bad thing or downside in that. But it is useful for if you're just looking at pH level of a solution without doing any quantitative measurements. So that's really it for pH or indicator.